Welcome to Martin's Institute of Teaching. In this video we're going to be working with unsigned binary numbers. In particular, the first thing I'm going to show you guys is how to convert unsigned binary numbers into decimal. And then from there we're going to go ahead and show you how to convert larger decimal numbers into binary or unsigned binary numbers. So first thing here is let's go ahead and convert this value right here. So when we're dealing with unsigned binary numbers, every of these bits represents either a 1 or a 0, and that 1 or a 0 tells you if you have a power of 2. So this first value, well, let's go ahead and just put these here. The first, so if I have a number like this, let's say I have, if I have 1, 1, 1, 1, 1, 1. This would be, in computers, we always start off with 0 at the first one, which that would be a 0. Or the 0 place. This is the first place, second place, third place, fourth place, fifth place. Let me just clean that up. So, and when you're determining what value you have, you actually, what this is telling you, this is your power. So this would be 2 to the 0 power. This is 2 to the first power. This is 2 to the second power, 2 cubed, 2 to the fourth power, and 2 to the fifth power. So when I look over here at this unsigned binary number and I see this one right here, the first thing I know is this first one represents this one position right here, or the 0 position, which is 2 raised to the 0 power. So this represents a 1. This one is a 0, so since it's a 0, I don't add this 2 to the first power, which is 2. So for that, I would just get a 0. But really what this is doing is saying, okay, so if I have this 0, if you're going to separate it, it's 0 times 2 to the first power plus this one, which represents a 1 here, which is this one, times 2 to the first power, which is that right there. Oh, no, I'm sorry. This this one right here represents this one, which is the 0 in the 0 place, which is 2 to the 0 power, which is just 1. Sorry, that might be a little bit confusing, but we'll do a bunch of these so it becomes much clearer. So this is 0 times 2 to the first power, which is just a 0, plus 1 times 2 to the 0 power. 2 to the 0 power is 1, so this is 1 times 1, which is just 1 like that. So 0 plus 1 is 1. So this value over here, 0, 1, in binary represents 1 in base 10, or that's just how we normally count. So now we're going to go into this one. So 1, 0, 1. So this first one represents this position here, this 1, and it's 2 raised to the 0 power. So that's going to be, no, let's just start with this one. So this is 2, or this is this 1, so I have a 1 here, so it's going to be 1 times 2 to the 0 power, plus this next one is a 0, so it's just going to be 0 times 2 to the first power, and this next one is going to be 1 times 2 raised to the, and since it's going to be in this position, it's in the second, well, for computers it starts with the 0, so this is 0, 1, and 2, it would be the second position, so it would be 2 raised to the second power. Like that. So for this, we get 1 times 2 squared, which is 4, plus 0, well, 0 times anything is always 0, and it's 1 times 2 to the 0 power. 2 raised to the 0 power is 1, so this is just 1 times 1. So this value right here, 4 plus 1, is just going to be 5. So 1, 0, 1 in binary, or base 2, is equal to 5 in base 10. So let's go ahead and do another one. Let's see, this one. So if we did this one, this is going to be the same as saying, okay, this first one is raised to, so this is going to say it's 1 times 2 to the 0 power, plus this next one, which is, oops, sorry, which is 1 times 2 to the first power. Oh gosh, I'm running out of space. Darn it. Let me move this over a bit. Didn't give myself enough space. This is 1 times 2 to the first power plus this one. And this represents 1 times 2 to the second power. And so 1 times 2 squared, that's going to be 4, because 1 times 2 squared is 4. This one is just going to be 2 raised to the first power, so it's going to be a 2. This is going to be just 1. So we're going to get a value of 7. So what we're doing is we're saying, okay, this first value represents, if you were to write all these out, you would notice that this first one represents a 1. This second position represents a 2. This position represents a 4. And if you kept going, like if you had more 1s here, then you would get 8, 16, 32, 64, 128, and well, I'm out of space, but it would just keep going. So this represents, this would be a 1, 1, 1, 1, 1, 1, 1, 1. So it'd be a, let's see, it's got 1, 2, 3, 4. This would be a, well, if I condense it down, it'd just be a binary number with 8 bits. So it'd be 1, 2, 3, 4, 5, 6, 7, 8. This represents, well, it'd represent all of these if you added them all up together. So that can be a bit confusing, but it's really not that bad once you get the hang of it. So for this one, let's see. And by the way, this gets really annoying when you get really large numbers. So like if your professor tells you to convert some number that's, whoops, that's like 32 bits, then that can be really annoying. But there's other ways to do that instead of this way. But for now, we're just going to be doing it this long-handed way. So okay, number 4, let's say we have a 4-bit number. Let's say that 4-bit number is 0, 1, 1, 0. So this would be, the first one is always going to represent a 1. This is a 0 plus 0 plus 0. And this one, this is in the 0, 1, 2, 3 spot. Whoops, sorry. Okay, so this one is in the, so this would be 0, 1, 2, 3. So this is just going to be 2 cubed, which is 8. So this value would be equal to 9. If we did it the same way we did it over here, this first one is going to be 1 times 2 to the 0 power plus, and well, these are just going to be zeros, but that would be 0 times 2 raised to the first power plus 0 times 2 to the 2 squared. Sorry, that's a little bit sloppy. Let's do that again. 2 squared plus, and this one is going to be 1 times 2 cubed. So this is a long-handed way of working out this problem. But, I mean, it's probably, you don't have to write out all these steps, it's just so you see where they're coming from. So let's do the last two, and then after these two, we're going to go ahead, or I'm going to go ahead and show you how to deal with numbers that are much larger than just, you know, this is 5 bits, this was 4 bits. You can see how, you know, progressively the more bits you get, the worse it's going to be. You can just imagine if you had to do this 32 times, it'd be a real pain. So here we have this value right here. So this first one, again, it's going to represent 1, that's a 0. So this is 1, 2, 4. This would be 8, but that's actually, well, this represents the 1, 2, 4, 8, and 16 spots. So if I look at this number, it tells me I do have a 1, I don't have a 2, I have a 4, I do not have an 8, but I have a 16. So that, I think, is a little bit easier to do it, but I mean, you don't have to do it that way. This value, this 10101, represents 21. So, and then we have this value here, 11001. You could write this value out like this. Well, I guess since there's only 5, I will do it that way. Normally, you don't do it this way because it takes forever, but I'll just do it just so you can see. So this is going to be, let's see, 0, 1, 2, 3, 4. So this is going to be 2 to the 4 power. Oh, gosh. I want this neat. So 1 times 2 to the 4 power, or as neat as I can make it, plus this is going to be 1, or actually it's 0. That's 0 times 2 cubed, which represents this value right here. The next one's going to be plus 1 times 2 squared, plus, and then this one's a 0. So it's going to be 0 times 2 to the first power plus 1 times 2 to the 0 power. So this right here represents this value right here, 1, 0, 1, 0, 1. So this first one is right there. This 0 is right there. This 1 is right there. This 0 is right there. And this one is way over here. Okay, that's just so you can see where they're coming from. Let's get rid of those. Okay, but now by doing that, I don't have enough space to do this value right here. But if we'll just do this one real quick. We already know that 1 to the 0 power is going to be 1. This would be 2, 4. That's going to be 8. So it's going to be plus 8. This would be 16. So it's just, let's see, 16 plus 8 is 24, plus 1 is equal to 25. So 11001 is equal to 25. You notice this one right here is 10101 is 21. So yeah, I mean these are pretty straightforward. It doesn't really become much of a pain in the butt until you get into values that are like huge in the thousands. So I'll save that for the next video. So I hope this was a good refresher for you, and I'll see you in the next video.